Hello, this is the Expo video for Team Acadia. On our team is Cam, Blake, Cody, Jack, and myself, Colin. And this semester we worked with Rocky Mountain Fire Station 5 in Superior, Colorado. Our direct contact at the fire station was Craig Holm, who we were connected with through the fire chief, who Dr. Soltis knows. Craig is the director of rescue operations and came to us with a unique problem to solve. The fire station installed a 70 grand steel structure in their apparatus testing bay and have been using it for over a year to conduct SPRAT certification training for their firefighters. SPRAT stands for Society for Pro Rope Access Training, and a certification is needed for each firefighter, which can cost upwards of $17,000 per firefighter if they do not build their own structure. This training is valuable because firefighters get hands on experience with failure and how to handle it in the field. Part of the structure is a set of two parallel I beams, which are about 22 feet tall. Having the structure installed greatly brought down training costs for the station. Our job with the Superior Fire Station was to design an enclosure that could handle up to 200 kilograms or about 450 pounds, provided by the fire station in the form of nine 50-pound weights, and design a tracking system that will allow the weight to be raised and lowered, as well as occasionally dropped for testing and training purposes. The firefighters would be roped into the system two times, and they would train by transferring tension between the ropes and catching slack if the other person made a mistake. If both firefighters were to make a mistake, then the worst case scenario would be that the system crashes to the floor. So we plan to design an appropriate crash pad at the base. The I-beams have some imperfections, such as the lateral offset at the base of about 1.5 inches, and they bow out towards the top about 0.25 inches every 13 feet. These imperfections were large constraints in our design, which our team has thought solutions for. We began the design process by taking measurements of the I-beam dimensions at the fire station, researching materials such as 6061 aluminum and 1045 carbon steel for a base, and doing hand sketches of possible designs under the constraints of needing a low friction tracking design able to hold up to 200 kilograms and not crack the concrete if it impacted the floor. Our initial plan after visiting the fire station and discussing a budget with them was to create a rectangular cage with offset spring loaded wheels to contact the I beams and keep the system upright. After this initial idea, we moved into the prototyping stage and designed an 8 wheeled frame that the weights could sit on and track up and down. We eventually decided that we'd need multiple points of contact at different lengths to avoid roll and torque on the system, and we scheduled a consultation with Rachel Sharp from the ITL, who referred us to Brandon Torres at High Tech Automation, who specializes in design using 80/20 extruded aluminum. We iterated on our prototype and went to their office in Golden to finalize the design. And here's our final design, some pictures and CAD drawings of that. It consists of a frame constructed out of 80/20 using their fasteners, wheels, and high-speed linear bearings. We also purchased the 20-foot rail of 80/20, which we will mount vertically on an I-beam, one of the two I-beams, using rubber and metal washers. These bearings will track perfectly along the rail, and ideally the wheels and bearings will be non-load bearing and simply there to provide support. The final critical part of the design is the steel plate and dowel welded together and fastened at the base of the 80/20 layer. We screwed in the eye bolt at the top, which a rope will attach to and bear the load of the whole system. Here's a block diagram to kind of document the rest of our process throughout the project. Just a simple visual representation of that. After our meeting with Rachel Sharp is really when things got put into high gear for our project, and the consultation with High Tech Automation was especially important to the success of our team. This is what the final design really ended up looking like, and also here is a simulation of the design in motion. Overall, for our team, this was a tough project. There's a lot of stress hanging over our heads for quite a few reasons. The project itself was pretty expensive, so missing things or causing an accident would be quite problematic. If we messed up big time, we could even damage the concrete in the fire station, which is something that we really didn't want to be responsible for. And lastly, of course, we wanted to make sure that we didn't waste the department's time or money because those things are very important resources to the fire department, an already important organization itself that's responsible for saving lives every day. As a result of these various stresses, we moved pretty slowly and were at times nervous to commit to purchasing parts and materials. If we could go back, it would have been ideal to be connected with this high-tech automation sooner in the design process, so that we could have purchased parts a lot sooner in the semester. Our project also ended up being a lot larger than we originally anticipated. If we had moved faster, we could have spent more time addressing the two other major parts to the project that we didn't really get around to. One of those is a crash pad design, which proved to be a lot more complicated than anticipated because of the weight and accelerations that we're dealing with, and also the installation of the 20-foot rail to the I-beam. As a result, both of these tasks have yet to be completed, and parts of the team will continue working with the fire station in May to complete it. Overall, our team worked fine together despite some occasional miscommunications, which caused some slight delays. But overall, it was a very beneficial experience for all of us, and we really learned a lot about engineering and working on a project as an engineer. And finally, here is some footage of the completed project. Thanks for watching our video. Hopefully you learned something and got a good picture of what we worked on over this semester.